Hi, welcome to the video lecture on measures of center. So one of the key things we like to know about any sample or population is what is the center of the distribution. There are three measures we look at. It's the mean, the median, and the mode. The first thing I need to say is that the term average doesn't necessarily refer to the mean. The term average is used to describe the center of a distribution. It could be the mean, the median, or the mode. So be careful with that. The next thing I want to say is I know you've probably been in classes before where you've seen mean, median, and mode. But I think we're going to cover some things here that you might not necessarily have seen before. So stick with me. All right, so notation in this course is really important. And we start with the sample mean, which is X bar. In journal articles and in your textbooks, it's sometimes denoted with a capital M. Either one of those is fine, X bar or M. The population mean is this lowercase Greek letter mu. The number of observations in a sample is lowercase n. So anytime throughout the course that you see lowercase n or even uppercase N in a formula, that refers to the sample size. Okay, so symbols are very important, so I strongly recommend start to make a list of them and kind of keep a running list. All right, so if we're talking about the formula for X bar, that's the sum of the x's, which is what this symbol means here. This sigma, this capital sigma x means take the sum of all the x's and divide by the sample size. I've got an example here, which I'll skip over. The median is the middle number of the data once you put the data in order. So you put the data in order from least to greatest. If the sample size is odd, then you just pick the middle number. If the sample size is even, then you just take the mean of the middle two numbers. All right, and I'm going to skip over this example. You can read it in the PowerPoint if you want to. I think it's pretty self-explanatory. The mode is the most frequently occurring observation in a data set. The thing with the mode is it doesn't necessarily have to have a mode at all. It could have one mode, or it could have more than one mode, which limits the usefulness of the mode. And again, here are some examples that I'm going to skip over. You can look at the PowerPoint and read it if you want to. Let's look in StatCrunch at how to calculate the mean, median, and mode. So I've typed these values into StatCrunch already. All you do here is you go to Stat, Summary Stats. We've got our data in columns, so click Column. Select the variable and move it over. And then we pick whatever stats we want. And the way I usually do that, there may be more than one way, but click the first one you want, and then hit Control, and click the second one, and then click Control, and the third one. Okay? So hit Compute, and here we have the mean, median, and mode. Okay? And to copy this on your homework, you'll just select it and Control-C, and then Control-V it into your file. So that's how to do that in StatCrunch. Let's talk about the effect of outliers on the mean and the median. So suppose we had this data set, 73, 75, 80, 83, 85, 92. We calculate a mean of 81.3 and a median of 81.5. Now, what if we changed that first observation to make it be a 7 instead of a 73. So what happens is then this data set has an extreme observation, the 7. What's the effect on the mean? Well, you can see it changes the mean by a good bit. It changes the mean by 11. But the median is not affected at all. So the mean is much more susceptible to outliers. Okay, and that's a key point, because that helps us choose when to use the mean and when to use the median. Okay, so we've got 3 different measures of central tendency. And the question is, for one thing, why do we need more than one measure? And then when would we choose to use one over another? So the mode is really the least useful, partly because, as we said earlier, there's sometimes more than one, sometimes there's not one at all. So that's part of it. But also it's just not that good of a measure of center. The only time you'd really want to use the mode is if you're talking about something where there are only a few possible values, like the most frequent number of children in a family, the most frequent number of bedrooms in a house in a certain neighborhood, something like that. A benefit of the mode too is that it can be used with nominal data, and that's the only one of these that can be. So otherwise we don't use the mode very much. Now, we use the median because it's not affected by outliers. We'll use it when there's a data set where there are outliers, because we're really looking for what's the center. We're looking for what's a representative or a typical value. If you've got outliers, that's going to pull the mean up or down toward the outlier to the point that the data doesn't necessarily, that it's not really representative anymore. So that's why you'd use the median. Anytime you're expecting outliers or a distribution that's really skewed, you'd use the median. Otherwise, you just use the mean. So next, let's look at how you would look at measures of center in terms of a distribution. So the mode would be the location on the x-axis, if you're looking at a histogram, I'll show you in just a sec, of the highest peak. So wherever the highest peak is, that's where the mode is. The median is going to be the value so that there's half of the area to the left and half of the area to the right. Whereas the mean is the balance point of the distribution. And when we talk about the balance point, if you can imagine the distribution is sitting on a ruler and you're trying to balance the ruler on your finger. So you're trying to hold your finger straight out and balance a ruler, like if you put pennies on it or something, trying to balance it. So here's an example. This is just a data set I made up, and I made it up so that it's strongly skewed to the right. This one has a mean of 2.1220. So that's right about here. That's where you would need to hold your finger to balance this distribution. The median is 2. So the median is that point where there's half of the area to the left and half to the right. And the mode here is 1. That's because that's the most frequently occurring value in the data set. So if you see, this is the relationship here for this distribution where it's strongly skewed to the right. We've got the mode being less than the median, which is less than the mean. And that's actually always going to hold when you've got a data set that's skewed to the right. If it's skewed to the left, it's going to be the other way around. And so what we were looking at, the histogram that I made, was an example of this, where when you've got a right skewed distribution, the mode is less than the median is less than the mean. If you've got data that's skewed to the left, it's going to be the other way around. if you've got data that's normally distributed, or if it's really any symmetric distribution, whether it's uniform, normal, bimodal but symmetric, the mode, the median, and the mean are all going to be about the same. Except if it's bimodal, then there's going to be two modes, but you get the idea. Okay? Let me stop the video here and we'll pick up there with the mean of grouped data.